Hi learners, I am Dr. Ganga, Associate Professor, Department of Biomedical Engineering, Hindustan College of Engineering and Technology. In this video, we will learn about signals and system, some standard signals, that is impulse and parabolic signal. First, we will learn about impulse signal. An impulse signal is one of the standard test signal. It is also known as Dirac delta function. An impulse signal exists only at 0, that is del of t is equal to infinite for t is equal to 0. Suppose the t value is not equal to 0 means the del of t value is equal to 0. This is a impulse signal condition. This is a continuous time impulse signal representation. How we generate continuous impulse signal? First of all, we take a rectangular of area 1 unit, that is a gate function. Then decrease its width in such a way that its area remains 1 unit. When width of rectangular function tends to 0, then height of rectangular function will be of infinite magnitude. It can also be generated by triangular function with sample concept. This is the generation process of continuous time unit impulse signal. Here we just take only, that is t values equal to 0 to 1 by t, then x of t, that is half of the values, that is t is equal to t by 2, here minus t by 2. This signal is generated to like, that is t is equal to 0 to 1, that is del of t values equal to 1. Some basic expression of unit impulse signal is, that is integration of minus infinite to plus infinite, the del of t into dt is equal to 1. Because the area under unit impulse function is unity, that is called as 1. This is an impulse function is an even function, means the expression is del of t is equal to del of minus t. The scaling property of impulse signal is, that is del of a into t is equal to 1 by modulus of a into del of t. Next, product property, that is equal to 0 for n is less than 0 where n is an integer. This is some basic functions of product property of impulse signal. Next one is a sampling or integration property of impulse function. This is a mathematical expression of integration property. Next, discrete time impulse signal can be defined as the following expression, that is del of n is equal to 1 for n is equal to 0. Suppose the n is not equal to 0 means the del of n value is equal to 0. The discrete impulse signal is defined by its magnitude, whereas continuous impulse signal is defined by area. Discrete unit impulse signal is also known as Kornoff delta or unit sample. Del of n is not affected by scaling. This is a properties of discrete time unit impulse signal. The first one is a symmetric property. This is a basic expression of symmetric property, that is del of n is equal to del of minus n. Next one is a scaling property. The scaling property expression is, that is del of n is equal to 1 means for n value is equal to 0. Otherwise the del of n value is equal to 0. Next one is a product property. Product property expressions are x of n into del of n is equal to x of 0 into del of n. X of n into del of n minus n is equal to x of n naught into del of n minus n naught. X of n minus n1 into del of n minus n naught is equal to x of n naught minus n1 into del of n minus n naught. These are the basic mathematical expression of product property. Next one is a summation property. This is a sigma n is equal to minus infinite to plus infinite. X of n into del of n means sigma n is equal to minus infinite to plus infinite. X of 0 into del of n, that value is equal to x of 0. Some applications of impulse signals are system analysis, control system design, signal processing and communication system. In system analysis, impulse signals are widely used to analyze the behavior of linear time invariant system. By applying an impulse signal as input to a system, we can obtain its impulse response which characterize the system's behavior. Control system design. Impulse signals are valuable tools for designing and analyzing control systems. They help to determine the system stability and performance of control system by evaluating their impulse response. Next one is a signal processing. Impulse signal play a crucial role in signal processing applications such as filtering, convolution, and system identification. For example, in digital signal processing, convolving a signal with an impulse response helps to characterize the system's behavior and filter out undesired component from the input signal. Next one is a communication system. In communication system, the impulse signals used in channel characterization and modular schemes. By transmitting impulse-like signal through communication channels can analyze channel characteristics such as impulse response and frequency response, which is crucial for optimizing data transmission and reception. Next, some advantages of impulse signals are simplified system analysis, universal response representation, mathematically simplicity, and time invariance property. In simplified system analysis, impulse signals simplify the analysis of linear time invariant system. By convolving the impulse response of a system with any input signal, we can obtain the system response for that input. Universal response representation. The impulse response of a system contains its behavior to a unit impulse input, which serves as a basic for understanding its response to any input signal. This unversatile allows us to analyze and predict the system's behavior for various input signals without needing to test each input individually. In mathematically simplicity means impulse signals are easy to represent mathematically. The impulse function typically denoted as del of t or del of n in continuous and discrete time domain respectively. Its mathematical simplicity facilitate analytical solutions and computations in system analysis and signal processing. Time invariance property. The impulse signal exhibit the property of time invariance, meaning that their response remain constant over the time. Next, some disadvantages of impulse signal, that is idealization versus practical realization. Next one is a physical constraint, and third one is a signal distortion. That is, the idealization or practical realization means the concept of an impulse signal is mathematically useful for system analysis. Practical realization of an ideal impulse signal is not feasible. Ideal impulse signal have zero duration and infinite amplitude, which are physically impossible to generate or measure. In physical constraints, practical systems and instruments have limitations in terms of bandwidth, resolution, and response time, making it challenging to generate or detect signal with infinitely short durations. Next one is a signal distortion, the main disadvantage of impulse signal. Due to limitations in bandwidth and signal processing capability, real-world impulse signals are subject to distortion and attenuation. Next one is a parabolic signal, the basic standard test signal. The parabolic signal is a signal whose magnitude varies a square of time, that is P of t is equal to t square by 2 for t is greater than equal to 0. Suppose t is less than 0 means the P of t value is equal to 0. This is a basic mathematical expression of parabolic signal.